Okay, welcome to day 3 of Intro to Object-Oriented Programming. Today we will dive into a topic, inheritance. Okay, inheritance is one of the pillars of object-oriented programming, and it's important that you know it. So let's dive in. Today, we are not going to review the content from last week. I took all of the review slides out because if you want to review, you can go back and watch the videos from last week. So hopefully that's okay. I would also like to introduce you to the pillars of object-oriented programming and dive into inheritance, which is one of them. We're going to talk about how we can use abstract classes to achieve our goals. I've got some examples of how we use inheritance here at Health Equity. And we're going to talk about how inheritance can be used in our movie night application. So there are 4 pillars of object-oriented programming. This is a very common interview question because it's an important thing to know about object-oriented programming. Okay, encapsulation, abstraction, inheritance, and polymorphism. I won't dive into these very much today, as this is what most of our course will cover. Except for inheritance, we're going to talk about inheritance a lot. Okay, let's think about inheritance in real life. First off, one principle is that inheritance is a relationship. So you could say that a golden retriever is a dog. You could say that a pit bull is a dog, right? A golden retriever and a pit bull both share the properties of a dog, and so they is a relationship. Now think about ice cream, right? Ooh, lunchtime and ice cream. Think about a bowl of vanilla ice cream, or a creamy popsicle, or a Klondike bar, or fried ice cream, right? All of those are ice cream, even though they have some properties, some data, or some behavior that are different that make them unique. All of them share certain properties, okay? And that's what inheritance does. You could say that all of these are ice cream, or a Klondike bar is ice cream. Okay, the reason we want to set up inheritance relationships in our code is we have a couple reasons. Okay, for one reason, when one class inherits from another, it gets all of its data and behavior. Okay, so basically the parent shares all of its data and behavior with any child class. Okay, a child class can extend the behavior. So if a parent does 2 things, the child class could do those 2 things and then 2 more things. And the way my college professor liked to tell me this was that my child is all that and a bag of chips, right? So if the parent is all that, the child is all of that and more, a bag of chips. Okay, and we'll need to do inheritance so that we can understand polymorphism. All right? So let's talk about how to do inheritance in C#. First off, we do inheritance with the colon syntax. You can see that here in the middle of the slide, we say public, we use the class keyword, and then we use a class name. And this is something we've been doing for about a week now. But in order to set up an inheritance relationship, after the class name, we type a colon and then another class name. And this says that the class before the colon is a child class, or is a type of the parent class, okay? So child classes get all of the data and behavior from their parents. Let's look at one example before we start coding, okay? You can see here that I've got a couple different mammals, okay? As we all know, there are lots of different special kinds of mammals, but mammals share certain properties, okay? So here, a mammal has a name and is hairy, and as you know, a dog and a dolphin are both mammals, but they're very different animals, okay? So a dog, colon, mammal, this says that the dog is a child class, or is a mammal. So is a dolphin. A dolphin, colon, mammal means the dolphin is a mammal. So we've set up this inheritance relationship, and then over on the right, you can see that I'm creating a dog, and a dog is a mammal, so a dog has a property named name and is hairy. Okay. Another thing here is you can see that so far, when we've created lists or arrays, we've required that all the elements in the list or the array are of the same type. And dog and dolphin are different classes, right? But we can store them in a list or an array of their parent type. So you can see down here at the bottom, we've got a list of mammals called all animals, and we can add a dog object and a dolphin object to these classes, okay? So let's write some code. I'm going to pop open here my test project, and I'm going to add a file, and I'm going to say inheritance example. Oh, I hope I spelled inheritance correctly. Okay, so in here I'm going to set up, let's do a public class fish, okay? And a fish has a couple different properties. For example, public int weight. Okay, and maybe public int water type habitat. Let's make that a string. Okay. So as you know, there are many, many different kinds of fish. So if I were to create some classes to model different kinds of fish, and I want them to inherit the properties of fish, first off, let's create the classes, public class shark. And just for funsies, let's call it baby shark. No, that'll be the object name, shark. Okay, and a shark has public int tooth count. Great. So I'm going to show you, well, let's create one more class here. What's a different trout? How about that? Okay, you can see here we've got three classes. We've got a trout, a shark, and a fish. And I haven't set up inheritance yet for a reason. I'm going to come over here to my program.cs, and I want to start using these classes, okay? First off, I need to create something to hold all of my fish, and I'm going to call it aquarium. So I'm going to say a list of fish, and I'm going to say this is my aquarium. Aquarium. Okay, and I want to add my trout, or a new trout, and a new shark to my aquarium. So I'm going to say aquarium.add new shark. Okay, let's go ahead and run this. So we've got some errors. Oh, they're all in the ticket assignment class. I'm going to delete that for now. Okay, after a brief interruption there, I did have to clean up some code real quick. I have now run my code and gotten the errors that I was expecting, okay? You can see the errors down here. Argument 1 cannot convert from shark to fish. Argument 1 cannot convert from trout to fish. So I'm trying to create a list of fish called aquarium and put my shark and my trout in there. You can't do it because these types, we're saying in our code right now that a shark is not a fish and a trout is not a fish. Okay, so let's go set up this inheritance relationship. So we're going to set this up by saying a shark is a fish. And we do that by adding the colon and then the parent type. Okay, now we're saying a trout is a fish. These errors should go away now. Okay, very good. And they do go away. And if I were to write the code that I really wanted to do, never mind. Okay, we've set up the inheritance relationship for now, but why would we do this? Okay, why is it important that we do inheritance in C#? All right, you can see here that we've created a new shark and a new trout. So I'm actually going to take these out and I'm going to say var baby shark is equal to blah. Okay, and then I will add baby shark to my aquarium. In similar fashion, I'm going to say var Mike trout is equal to blah. And then we add Mike trout. Okay, by setting up inheritance, we have now given access to shark and to trout. We've given them access to these two pieces of data. Okay? If we hadn't have done this and we had no fish class, then our classes would look a little something like this. Okay, the trout class would have to set up a weight property and a water type habitat, and so would the shark. So by setting up an inheritance relationship, we're saying everything that is a fish has these properties, and you don't have to redefine these properties as a fish, right? So the generally shared data and behavior go in the parent class, and the specialized or unique data and behavior go in the child class. As you can see here, our shark and our trout have access to these pieces of data. And if I can remember what they're called, water type habitat. Okay, baby shark can access, it has a water type habitat property because it is a fish. Okay, same deal with the trout. The trout can access the water type habitat because it is a fish. This is embarrassing. I can't remember the names. Bet you wish you could have those 30 seconds of your life back. I know I do. Oh, hell. Embarrassing. Okay, so something to note as you are putting objects of the same type into one aquarium or one collection is when they go into that collection, they have to be the parent type. So the specialized properties are inaccessible. All right. So if I were to come in here and I were to write a loop and I were to say for each fish F in aquarium, when I get to the first fish, I can't use properties on the shark even though I know it's a shark. Hey, this should result in an error for us. Fish does not contain a definition for tooth count, okay? An aquarium, or the aquarium, holds a shark and it holds a trout, but we're saying it holds fish, right? So we are treating them as the parent type, as fish. So we do not have access at this point to the tooth count. Okay, one way you can get around this is by casting. Okay, so we can ask the question if F, we'll say type of F is trout. Then we will cast this thing to a trout. Okay, surprise! I had to do some lookup to figure out type checking in .NET Core 2.2. So here you go. We have now correctly checked the type. So here, even though it is a fish, it is also a trout. So the way we check type is by using the type of operator. We say, take this type, give me the type of this trout, which will be trout. And we'll say, if it is equal to the type of F, then do this thing. Cast it to a trout. So casting is a new concept. We say, take F, and then we do open close parentheses, trout, and that makes it a trout, and then we can use its variety. Okay, so we can do a very similar statement here for sharks. All right, so we went through all of the fish in the aquarium and we asked some questions. We said, is this fish of type trout? If so, print out its variety. Is this fish of type shark? If so, print out its variety. So these two things in the aquarium, Mike trout and baby shark, are of type trout, and a trout is a fish, okay? And because we do these things, we can always print out properties about the fish. So we can say water type habitat. Without any casting, okay? So there is a lovely little lesson on the types that a class can be, okay? This first one is a fish and it is a trout. The second one is a shark and it is a fish, okay? All right. So let's talk about another example. If you think about the account types that we have here at Health Equity, we have health savings accounts and reimbursement accounts. And those are very different accounts, right? But they do have some things in common. Okay, for example, both of those accounts have a balance. My HSA account has a balance and my reimbursement account has a balance. I can take money out of them, I can withdraw, okay? But a health savings account is the one that I deposit money into, and a reimbursement account has a list of claims, right? So there are some things that are specific about a health savings account and a reimbursement account, and those behavior and data should go in a health savings account class or a reimbursement account class. But there are some things that are shared, and those can go in the account class that are the parent type of health savings account and reimbursement account. Okay, another important thing to know is the base keyword, okay? When you are operating in a child class and you want to specifically use some behavior from your parent class, you say base, okay? In this example here, we are using the base keyword to, after calling the health savings account constructor, we want to call my base classes constructor, so we're going to call the account constructor, okay? So here, health savings account constructor is called and it takes in an opening balance and an account name. All right, so you do my constructor's code and I say set the balance to the opening balance, and then after you've done that, call the account constructor and set the account name to the account name property in account. Okay, the base keyword is used to access functionality in the parent. It can be used to access constructors, or methods, or properties, or whatever you need. Okay. This is kind of a trick question here, I guess. Can you have different functionality of the same name in the parent and the child? Or in other words, if I have an account class and it has a withdrawal method, and I have a health savings account class and it has a withdrawal method, well, which one is going to happen? Okay. And the answer is, right now, with what we know, we can't make them different. We can't have methods defined in both the parent and the child, but there is a way to do it. It's one of the pillars of object-oriented programming. It's called polymorphism. Okay, and we'll learn about that very soon. But just know for now that property names and method names need to be unique in the parent and the child. Okay, so we kind of already did the practice here. We created the fish class, the trout class, and the shark class, okay? And then we created a container for all of them. So we'll skip this practice for now, and we'll talk about abstract classes. Okay, so abstract classes are a special type of class, okay? We learned last week that a class is an abstract idea, and an object is a concrete thing, okay? You can create objects from classes. But sometimes you don't want that to happen. Sometimes you have the fish class and you don't want people using your code to just create a fish. It doesn't really make sense to create fish. It makes sense to create a tuna or mahi-mahi, okay? But it doesn't make sense to create a generic fish. So sometimes we would want to make some classes abstract, and that is what we would apply to the fish class. An abstract class says, I am going to be the parent type only, and I'm never going to allow objects to be created from me. And that's done by using the abstract keyword, okay? Abstract classes can have abstract methods, and that makes it so that any child class has to define a method with that name. So let's dive in and do some practice, okay? Well, first here's the syntax. So it's very similar to making a regular class. We just add in one additional keyword. We say abstract, okay? And you can see that example right here. We're going to use public, and then we're going to say abstract class, and then we're going to give it a class name. All right, and then abstract classes are meant to be parent classes only. So we want to use them in inheritance relationships, and there's no difference there. We just say our child class is a abstract class, okay? And we use the abstract keyword. So let's look at our example here. Let's not do some practice. So we have a fruit class and a pear class. Once again, does it make any sense to say, I want a new fruit? No, it doesn't, because you can never just have a fruit. You can have a pear, or you can have an apple, or you can have a banana, but you can't just have a fruit. If you told your neighbor to go buy you some fruit, they would probably return with oranges when you really wanted pomegranates, okay? Fruit is a good example of an abstract class. Many types of fruit share properties with fruit, but we can never just have fruit. Okay, so here you can see that I am trying to create a new fruit, and I can't do that. I actually get a compiler error here that says you can't create a fruit because fruit is an abstract class, okay? Cannot create instance of the abstract class or interface fruit. But I can create pears, and I can create a pear and store it as a fruit, but I can't ever say new fruit. Let's go do some practice. So back in our example, I now want to make the fish class abstract. And I want to put the abstract keyword in the right place. Public abstract class fish, okay? Everything should still run because we aren't creating new fish. Okay, very good. So you can see here I'm storing these as fish, but they all have a specific type, and I'm not saying new fish. If I were to come in here and say var generic fish, and I tried to say new fish, okay, build error. Cannot create an instance of the abstract class or interface fish, right? Okay, so abstract classes, once again, are used to be parent classes only. They are used to share data and behavior, but also guarantee that we will never allow users of our code to create objects of that type. Okay, classes can have what are called abstract methods. So if we have the fish class and we want all fish to do certain behavior, we could define a method in the fish class, and all child classes that inherit from the fish class would have that behavior. But sometimes we want to say all fish have this behavior, but not allow, force the child classes to define their behavior, or in other words, don't share the behavior. We just want to make sure they have a behavior or piece of data with a similar name, but we don't want to give a default behavior. And that's done by using abstract methods. And you can see the syntax here. It's like a regular method, we just use the abstract keyword again. And another difference is we do not use open and closing curly brackets after the method signature. We put a semicolon because, as you can remember, abstract classes or abstract methods force child classes to do certain behavior but do not share any behavior. So this is what this could look like. So we have a mixer and then we have a KitchenAid class, okay? In the mixer, we have an abstract class and it has an abstract method mix. Okay, so KitchenAid mixer is going to have to mix. And then a BlendTech blender, it is a mixer, but it's a very different type of mixer. We did not implement a method called mix. Okay, and you can see here that Visual Studio is generating an error saying, hey, BlendTech has to implement the inherited abstract member mixer.mix, okay? So you can see here that because a BlendTech is a mixer, it has to know how to mix, but it's not going to get that mix behavior from its parent class. Okay, this is once again how we share behavior. It's how we enforce behavior is what I should say without sharing behavior. Okay, one thing that's very subtle in C# is that every type, every class, whether it's an int or a shark or a string or a health savings account, all of the types inherit from one type and it's called object. So if you ever find yourself in a place where you need to store lots of different things that are not the same type, you can always store them as an object. And you can see that example here, right? I have a list called everyone, and it holds objects of type object. And I can add ints to it and strings and characters and decimals and number classes or number objects, right? All very different types. I haven't set up the inheritance relationship. This is just something that C# does. It's implicit that all classes are of type object. So let's talk about some examples of inheritance here at Health Equity, okay? And I can show you the source code at a later date if you are interested. But just know that here at Health Equity, we've got a website, right? All of these websites, there are many web pages in the website. And there are activities that these web pages do that are shared, right? So there's some use of inheritance on all of our web pages. For example, there is an alert message functionality. If you've ever been on the website and had a little pop-up show up, that alert message functionality lives in a parent class that is the parent of all web pages. That parent class is called abstract content page. And if you visit any page in our portal that has a URL that ends in .aspx, then those pages have some functionality alert message to display a pop-up because those web pages are abstract content pages. Okay? There's lots of behavior like this for saving data or for retrieving data. They're generic things that all web pages do. So we shared the behavior. If we didn't share the behavior, then every page would have to have a method called alert message and wouldn't have to know how to display a pop-up. And imagine if all of a sudden all of the pop-ups needed to be purple at Health Equity. We would have hundreds of methods on web pages to update that. But because they all are inherited from abstract content page, there's one place where we have the alert message functionality, where if we change that, we're actually changing the hundreds of child classes, right? And that's the power of inheritance as well. It's much easier to maintain. So let's dive in. I will dive in, I guess. So I'm going to open our Health Equity solution here. Here in the Health Equity solution, this is the code that the engineering department works on daily. It contains code for projects like the website, and for console, and test harness, if any of you use those projects. So I'm going to move talking head here to the bottom. Okay, and we're going to find HE website. Then we're going to find some pages, maybe in the member portal. And let's find our favorite page, member home.aspx. So this web page has a couple different parts. Some of it is HTML and some of it is C#. Okay, so the member home page is a member content page, and that member content page is an HE content page, and that HE content page is an abstract content page. So you can see here we've actually got a child, parent, grandparent, great-grandparent, great-great-great-grandparent relationship. Okay, abstract content page has this alert message functionality right here on line 560. Okay, and all this does is set up some JavaScript to call a JavaScript alert. Okay, but if we were to look in Visual Studio and see all of the places where this is used, you can see here lots of different web pages. The member SIP failed handler, agent home, agent registration. All sorts of web pages use this functionality because all of these web pages inherit from abstract content page, right? So we've defined the code to pop an alert message in one place, abstract content page, and we've made it the parent or great-grandparent or great-great-great-grandparent of many web pages. So it's very easy to pop an alert message here at Health Equity. And also, if we had to make this alert message purple, we could come in here and add some CSS rules, and blammo, we have a purple alert message, okay? The power of inheritance right there. Sharing behavior, sharing the alert message method with many child classes. Okay, I'm going to skip over this example for now. Let's talk about how we could use inheritance in our movie night application. Okay, think about all of the objects that you've been, or the classes that you've been defining for the movie night application. Okay, there are some things that share data and share behavior, and each of those things also have some specialized data and behavior that they do not share. So think about theaters. Okay, when you go to the movie theater, you want to buy a seat to see your movie. Okay, and you get there, and the machine or the movie theater worker asks you if you'd like to see it in 3D or if you'd like to see it in the luxury theater. Okay, so there are lots of different kinds of theaters at the movie theater, right? All of these theaters have seats. Some of the seats are larger and they recline. Some of the seats are smaller and do not recline. All right, some of the movie equipment is different. There's a 3D projector, there's a regular projector. So think about how we could use inheritance here. Maybe we create a theater class, and then we have a 3D theater class or a luxury 3D theater class or a regular theater class. What data is unique to those types of theaters? Or in other words, what data goes in those child classes? What data and behavior is shared? Or in other words, what would go in the parent theater class? And does it make sense to make the theater class abstract? Do we ever want to just create a theater? I don't know. So we've also got different kinds of seats in the theaters. You've got, some of them have luxury seats. Some of them are those fancy D-box seats that rumble during certain parts of the movie. Some of them are handicap accessible. So think about the seats. What properties, what data do they share? Maybe those could go into a parent seat class. What data or behavior are specialized or unique to these seat types? Those would go in the child classes. So your assignment this time around is to create one inheritance relationship that could be used in our movie night application, right? I don't really care what it is, and it could be one of the ones that I just described, but I'd like to see some code that you've written to set up an inheritance relationship. Okay, that'll do it for this session. So as always, please reach out to us, Eric Tang or myself, if you have any questions or concerns, and best of luck.